Okay, so I hope Anas and Alas, both of you can hear me and you can see the screen. In previous class, I explained almost everything that we need for X-rays. Uh, Today, I will explain one more topic and then we will start solving questions related to these topics because both topics are related to each other. And that topic is basically CT scan because we are discussing medical imaging. And in that medical imaging, CT scan is a very famous technique. Now, the word CT scan is basically meaning computed tomography or computerized tomography. It is basically an advanced form of X-rays. So I guess Alan left. Okay. When we talk about X-rays imaging, X-rays produce two-dimensional image. Two-dimensional image means it won't be giving you the sense of depth. This is the same case when you watch movies on screen or anything on screen, even your picture. It is an example of two-dimensional image. It will tell you how broad you are, how tall you are, but how fat you are. Your picture will never reveal that thing until unless someone took your image from sideways or something like it. But if you have experience of watching 3D movie, yes, Anas, ever watched a 3D movie?
No, sir.
Really?
Yes, sir.
So not into movies actually.
No, sir, not really.
Okay. Because this is what 3D movies actually show. Because when we used to explain image formation by mirror, I used to say this thing that image seen on mirror or screen is two-dimensional. It will give you information about your width, your height, but it won't give you any information about your depth. Basically, 3D movies or 3D images actually gives you information about the depth as well. So the problem with X-ray images, it will gives you two-dimensional image. For example, if you take X-ray of stomach or any organ inside human body, let's say this is an organ and there's a mass which is building up. Let's say this mass is here. Now, X-ray will tell you there's some mass or there's some abnormal object which is represented by this red spot, but it won't give you any information about depth of it. For example, if I make a 3D image of the object that you can see, let me try, quite possible I can draw it. So it's not very easy because on two-dimensional surface, it's very difficult to draw a three-dimensional image. But I'm just giving it a try. Okay, so I hope this is giving you some sense of. Now, if I look at this red spot, so quite possible this red spot is actually this deep from one edge to other edge like this. Quite possible that red spot is not that deep, it is just like this. Quite possibly it is just a scar on the skin. Yes, Alana, are you getting the point I'm trying to explain? When you obtain X-ray image just gives you 2D information. What is the width and what is the height? X-ray image doesn't give us any information about the depth. If you need the depth, you will be needing a 3D image. CT scan or computed tomography is basically a technique with the help of which you will obtain so many 2D image of an organ or section of an organ, and then we will use some specialized computers to merge those images to generate a three-dimensional image. So X-ray is two-dimensional. In CT scan, we are still using X-rays. The only difference is under normal circumstances, we expose human body from one direction to get one image. But if you want to obtain CT scan or image of CT scan, you will be obtaining so many numerous 2D images, then you will combine them, 2D images, you will combine them to produce 3D image. To produce 3D image. And this needs some specialized computers. That's why this technique is actually very expensive. I'm not sure what is the cost of CT scan in UAE, but I can give you a comparison. For example, in Pakistan, if you are going for X-ray, I guess you hardly need to spend somewhere around 80 dirham or 70 dirham. But if you are going for CT scan, you need to spend somewhere around 1,000 dirham. So you can compare the difference of cost. X-ray is very cheap technology because it gives you only superficial information, what is present on the surface. CT scan gives you in-depth information about everything. What is the advantage of CT scan? You can view the object from 360 degree. You can rotate the image in any direction you want, and you can see it. For example, I don't know whether I can do it or not. Let me just give it a try. Let's say this is the object. What CT scan enables you, you can rotate this object any way you want. I mean, you can flip it as well. I'm not trying to do so, but advantage of CT scan is the image you obtain, you can rotate it in any angle to view the image from of any side, number one. But what is disadvantage? X-rays, as I mentioned in previous class, hard X-rays have good penetration, soft X-rays get absorbed, and every radiation has some harmful impact. And it's not like that you can isolate soft and hard X-rays completely. So when we take X-ray, definitely there must be some soft X-rays that keep absorbed in human body. So when you are going for CT scan, you will be exposing human body to X-rays so many times that it could be having more health hazards than X-ray. Are you people getting it? Because sometime in exam, they do ask, what is the drawback of using CT scan? Despite of the advantages, there is drawback that we need to expose the patient to X-rays for longer duration and for so many time. Quite possible you might have seen CT scan machines. In CT scan machines, we have a horizontal surface on which the patient will be resting, on which the patient will be resting. Then there is a source of X-rays. There's a source of X-ray from where the radiations will come. So let's say the X-rays are like this. Let me draw it first, then I will shortly explain what I'm trying to say. Behind this bed, we will be having a detector that will detect the X-rays which are emerging out of the patient body. And what these X-rays carry as information will help us in obtaining the 3D image, right? Now, this entire setup can be rotated 360 degrees. The entire setup can be rotated 360 degree. And the last thing, this surface is actually coated with material that can protect the surrounding from the X-rays. I mean, X-rays cannot go out of this. Let's say this is an X-ray that is striking the surface. Here we won't be having anything because this is the shield that absorb all the X-rays. Now, this hello. Okay, now you people can hear me. So, may I know what was the last thing that you were able to hear?
Sir, something about shields and you're not sharing your screen.
Okay. Okay, so what I was saying that the entire setup is covered with a shield so that X-rays cannot come out of that region. Now, what is important? These radiations or these X-rays are thrown on patient body at 4 different angles. Those 4 different angles are actually 0 degree, 45 degree, 90 degree, and 135 degree. And quite possible because about Anas and Anal, I am sure that you are taking math, so you will agree. After that, all other angle will be the repetition because after 135, we will be having 180, which is repetition of 0. We will be having 225, that is repetition of 45. We will be having 270, that is repetition of 90. Then we will be having 325, if I'm not 335, in fact, 315. We will be having 315, that is similar to 45, and 360 is 0. So patient body is kept in a manner that we will be throwing X-rays on it for at 4 different angles: 0, 45, 90, and 36, and 135. And why do we do so? To obtain several two-dimensional images for the same organ or same section of the organ, so that you can combine those images to obtain a three-dimensional image. To obtain a three-dimensional image. So how we do so? Now listen it very carefully because this technique is very difficult to perform, but very easy to do on paper. So obviously you will get to know how to calculate it. So how we calculate? In CT scan, what we do? We obtain array. In computer language, array actually means storage of information, a pattern through which information is stored. If someone of you has some experience or knowledge of computer programming, he or she might be aware of this terminology. Array. Array means storage of information. Arrays are placeholders, just like containers, where you put your data. I'm just simplifying the thing so that you can understand. Normally, in CT scan, the arrays we use are actually 8 voxel cube. Now, what is 8 voxel cube? You will understand it if I show you how a 2x2 voxel look like. Let me draw it first. And before I start explaining, let me do just one thing. Because I will be needing so many such images. So just to save time. Okay, this is called 2x2 voxel. Why 2x2 voxel? Because it has one row here, one row here. So two rows and two columns. Those who are aware of matrices, quite possible they are able to recall it looks like a matrix. So arrays actually looks like matrix. They store data in similar pattern. So this is called 2x2 voxel. This is just 2x2. In CT scan, what we usually use is 8 voxel, but it's a cube. It's a three-dimensional image. During the entire topic, I will just keep on teaching you 2x2. But actually, what computer will be generating, computer will combine these 2x2 voxels to generate three-dimensional images of everything. Now, what actually be filled in these values? When X-rays are falling on these voxel, there is the detector that will receive what comes out. So what will actually happen? When these X-rays keep on passing through the organ, some amount of X-ray being absorbed by the organ. So what will be coming out won't be having the same intensity as the incoming X-ray. Do you agree? When X-rays are falling on an organ will surely absorb some X-rays. So what is coming won't be as intense as the incoming X-ray. So on screen or this detector will detect what is the loss. Let's say this is intensity of 10. I'm just simplifying this. What detector detects is 2. So it means that almost 8 is being absorbed by the organ. What this voxel actually contain? This 8 is not absorbed from here to here. Quite possible 6 is absorbed here and 2 is absorbed here. Or quite possible 1 is absorbed here, 7 is absorbed here, quite possible 5 is absorbed here, 3 is absorbed here. But in all together, what is being absorbed is 8. What is being absorbed is 8. Are you people getting it? What I'm trying to say? The detector will tell you what it is receiving. So it will visualize. So this is computer technique. So it wouldn't be as simple as I'm telling you. For example, how quickly a computer can perform operations. It is quite possible you know that in a second, they actually perform billions of executions per second. When you say your processor is of 1.6 gigahertz, now what this gigahertz means? If I'm not wrong, giga means 10 power 12 because mega is 6, tera is 9, so giga should be 12. So 10 power 12 hertz means 10 power 12 executions in 1 second. So computer can perform these many execution of instructions per unit time. So this detector will detect what is the decrease in intensity of X-ray. It will keep on repeating it to visualize that initial of the organ is absorbing this, final of the organ is absorbing this. Now, this is the core idea that we keep on using throughout this topic. Now, let me explain a few things. After that, I will ask you how much you actually able to understand. Let's say I took a voxel. I put it here. I don't know what is the absorption capability of the organ. But for the sake of understanding what I'm doing, I'm using any random value in this combination. I'm using any random value. For example, let's think of any number. Let's say I write 4, I write 2, I write 3, and I write 7. I have put these values. Computer won't be needing these values because after performing all the operation, I will end up with this thing exactly. So what computer will be saying is something like this: a blank voxel. Computer doesn't know what is written at these spaces. This is what I am telling you, that it is 2, 4, 3, and 7. Now, step number 1. Step 1. Step 1 means 0 degree. Step 1 means 0 degree. X-ray will come from here. X-ray will come from here. So what will be the impact of it? The impact of it will be the sum of these two row wise will be 6 and 10. The sum of this is 6 and 10. Now there is another array which is known as memory array or memory voxel. So this is memory. Let me write here so that you remember. Now we got 6 and 10. What computer will do? It will store this data in an empty voxel. So this is row information 6. So it will copy it like this: 6, 6, 10, and 10. This is step number 1. 6, 6, 10, and 10. So remember one thing. This is what detector will detect. This is what computer will feed in the memory. 6, 6, and 10. Let me perform at least 2 steps. You will surely be able to understand how this system is actually working. Next will be step 2. Step 2 is actually 45 degree. So what we will do for step number 2, we will take the same voxel, but this time X-rays will be coming at an angle of 45 degrees. So it will be like this. Okay, let me use the similar color for X-rays. 1, 2, 3. So if we do so, detector will be here now. And this detector will detect 3 numbers now: 2, 7, 7. Are you getting it? Just visualize. This arrow is going like this. This arrow is going like this. And this arrow will be going like this. So we will get 2, 7, 7. Now, if it is 2, 7, 7, so we need to fill this. Now, how will you fill this 277? See, it will go in this voxel like this: 2 here, 7 here. This 2 is actually this 2. This 7 is actually this 7. What about this 7? It is going to fill the two cells. So it will become 7 and 7. It will become 7 and 7. Those who are still confused, just wait for next. Then I will ask you how clear everything was to you. Now, what it has in memory was actually this cell. Was actually this cell. So what computer will do? Computer will add them, and we will be able to get a new voxel, something like this. Now just add the corresponding. So can I say it will become 6 plus 7 is 13, 6 plus 2 is 8, 10 plus 7 is 17, 10 plus 7 is 17. So now the new memory is 8, 13, 17, 17. The next will be in this sequence, we are done with 0, 45. The next will be 90 degree. For 90 degree, we will be using the same setup. Now this time, X-ray will be coming from 90 degree angle like this. So I think many of you can easily tell that we will be getting 11 here and 5 here. Just imagine X-rays are going like this. So 4 plus 7 will give you 11 and 2 plus 3 will give you 5. So the new voxel that detector will establish will appear something like this. Something like this. 5, 5, 11, 11. Now, plus what we have in memory now? In memory now, we have this voxel. So computer will add these two. When computer add these two, we will be able to get 13 plus 11 is 24, 5 plus 8 is 13, 17 plus 5 is 22, and 17 plus 11 is 28. So computer will give us this memory now. So this is actually step 3. By the way, how many of you are actually able to understand even a little bit of it? I'm not expecting that you are getting everything of it. Yes, Amna, Alan, are you getting what I'm doing? Okay, if you are getting it, the next step is step number 4, where we will talk about angle of 135. So for 135, we will take the original array, which was this one. And in this case, we reached till 90. Now we will be using 135. So 135 means like this: 1, 2, and 3. So if I'm doing so, I will get this information. This is 3. This is 9 and this is 4. Now, detector will make a 2 by 2 voxel in which we will be having 9 and 9 like this. Here we will be having 3 and here we will be having 4. What do we have in the memory of computer? This voxel, last one. We will add them. Is equal to now if I add them 24 plus 4 will become 28. 13 plus 9 will become 22. 28 plus 9 will become 37 and 22 plus 3 is 25. Now I hope I have made all calculation correctly, because if any one of them is wrong, we won't be able to conclude the result and then we will see where we actually made the mistake. Now this is the final array that you will be getting 22, 28, 25 and 37. Now just do one thing. Scroll up and look at step number 1. In step number 1, when you got this 6 and 10, this is something that computer will be obtaining directly, because computer is unaware of these values 2, 3, 4 and 7. So this is actually known as background. This is actually known as background. And how do we calculate background? The sum of 6 and 10 is actually 16. So if I add them, 6 plus 10, I get 16. This 16 is called background. Okay, let me do one thing. Change the color of it. This 16 is known as background. And how do we use this background? Now see, the background voxel is like this, because we have only one digit, which is actually equal to 16. So it means that all the cells should be 16 in each. What we will do, up till now we were adding the voxel. This time we will subtract the last 2 by 2 voxel that computer has generated and the background, and see what we will be obtaining. So what we will obtain is something like this. So if I start subtracting 28 minus 16, what we will be getting? 12. 22 minus 16 is 6. 25 minus 16 is 9. And 37 minus 16 is 21. What I have done, the last voxel that we have in memory, we will subtract the background voxel from it. We got 6, 9, 12 and 21. Now 0 degree was actually the step to get background radiations or background value, right? If we exclude this, how many steps we have actually performed? 1, 2 and 3. Because 0 degree was background, we have already used that. We have performed 3 different steps. What I will do, I will divide this voxel by 3. If I divide this voxel by 3, now I hope all calculations are correct. See what we will be getting. 12 over 3 is 4. 6 over 3 is 2. 21 over 3 is 7. And 9 over 3 is 3. Now just look at this. Let me use some different colors so that you can focus. Look at this voxel and look at the voxel with which we actually started. They are the same. 2437, 2437. Actually, computer starts from this step. This step is the starting point of computer, because I was trying to explain you, so I assumed it like this. Computer starts from this step. It keeps on performing these calculations, and it eventually get to know that if we are getting 6, it is actually 2 and 4. If we are getting 10, it is actually 3 and 7. Now, by doing this, we just got one 2 by 2 voxel. Now, computer will keep on doing this calculation 1,000 or million times, and it will produce so many 2 by 2 voxel that it will be in position to generate a 8 voxel cube. That 8 voxel cube will enable us to see a 3D image. Yes, Amna and Anas, are you getting it? How did I calculate? Okay, now the amount of time I have taken, I took somewhere around, you may say 35, 40 minutes to perform this calculation. So obviously in exam, they won't be giving you a question like this where you will be doing all this until unless it's a very lengthy question and you need to explain CT scan in detail. Generally, what they will be doing, they will be giving you almost all the information except few, and you would be deciding those, performing those few steps actually. So this is how CT scan is actually performed. So there are 4 techniques in medical imaging. X-rays, we are done with that. CT scan, we are done with that. Next will be ultrasound, and then fourth will be MRI, magnetic resonance imaging. So those 2 topics we will be discussing next. As now, we will be solving few questions related to these topics. So just give me few minutes so that I can share few questions, because I think we should solve few questions related to CT scan because I just explained it, and those will be small questions. Then we will be solving questions on X-rays, the topic that we covered in previous class. So just give me a minute. Okay, I just uploaded a worksheet on Google Classroom. It contains two questions related to CT scan. Okay, try to answer question number one. Once you are done solving question number one, let me know. We will discuss the answers. Yes. Now, are you done solving it because your hand is raised? Okay, let's discuss the answers for this question. Briefly explain the principle of CT scanning. It's a 6-mark question. Now, what I'm doing, I'm just writing down the key points that you should have mentioned. See, if this is the organ whose 3D image you want to build up, computer what will be doing what? It will be dividing this shape into number of sections or number of slices. So step number 1, X-ray of a section is obtained. Number 2, we will repeat it from different angles. You can make reference to 0, 45, 90, and 135 degree. Number 3, you will process all the images, process all the images. Why? To obtain 2D image of the section. It means that up till now we are dealing with one section only. Now what you will do, you will repeat the procedure from step 1 to 4 for other sections or slices. Why? To obtain 3D image. To obtain a 3D image. So it's a 6-mark question. You need to mention 6 points. By the way, how many of you were able to compose something close to this? And how many of you are actually able to understand what I have written? Yes, Alan and Amna, are you getting it? What you were supposed to write in this? Because even if you memorize it, it will work, because almost in every question related to CT scan, they will ask the same question. And sometimes they ask why CT scan is expensive, or why CT scan cannot be done using without using some specialized computer. Even then you can mention the same thing, because this kind of execution or steps cannot be performed by unspecified or non-specialized computers actually. A simple section through a body consists of 4 voxels as illustrated in figure 10.1. An X-ray image of the section is obtained by viewing along each of the directions shown in figure 10.1. Now, everywhere you can relate 0, 45, 90, and 135. The detector reading for each direction of viewing angle are summed to give the pattern of reading shown. So this is actually why I highlighted in yellow color, so that you can relate. This is the last voxel. In the exam, they have given you the last voxel that you will obtain. See what question is saying. An X-ray image of the section is obtained by viewing along each of the directions shown. The detector reading for each direction of viewing are summed to give the pattern of reading shown in 10.2. For any one direction, the total of detector reading is 16. So this is actually background reading. This is actually background reading. Now what they are saying, on figure 10.1, mark the pattern of pixels for the 4 voxel sections. So what does it mean? You need to subtract 16, 16, 16, and 16, because this is background. What we will end up with, 25 minus 16 is 9. It will be 6. It will be 18, and it will be 15. Then you will divide it by 3. So when you divide it by 3, we will end up with 3, 2, 6, and 5. So I will get 3, 2, 6, and 5. By the way, how many of you actually got the same answer? 3, 2, 6, and 5. Amna, what about you? Were you able to solve this part? Okay. Now try to solve the next question. Once you are done solving it, let me know. We will discuss the answer. Anas and Alan, are you done solving this question or?
Yes, sir, I'm done.
Okay, you are done. What about you, Alan?
I'm doing good, sir. I was just raised for the first one.
Okay. So once Alan and Amna, are you done solving question? Raise your hand, then we will discuss the answers. Okay, so let's quickly discuss the answers. So background reading is 19.
Yes, sir.
Yes, Amna. Are you getting the same?
Yes, sir.
Okay, background reading is 19. Determine each of the pixel readings. So what you will be doing, you will be subtracting 19 from each and dividing by 3. So starting for A, 25 minus 19 is actually 6. 6 divided by 3 is 2. 34 minus 19 is actually 15. So it will become 5. 28 minus 19 is 9. It will become 3. 46 minus 19 is actually 27. So it will become 9. So are we getting the same 2, 5, 9 and 3?
Yes,
If
sir.
I'm going in alphabetical order. Amna, you are getting same?
Yes, sir.
Okay. Use your answers in B to determine the pixel readings along the direction D3 and direction D4. Now, what is D3? D3 is 90 degree. D3 is 90 degrees. So 90 degrees this one. If this is 90 degree, so can I say it will be 5 and 14? Are we getting the same? You could have written 14 and 5. It's the same thing. Yes,
Yes.
Anas, Amna. Okay. Direction D4. Now, D4 is this direction. So if D4 is this direction, it should be 2, 8, and 9. Are we getting the same?
Yes, sir.
Amna, are you getting the same answer?
Yes,
Okay,
sir.
so these were the two questions related to CT scan. Now, let's solve some question related to X-rays. So this is question number 4, page 177. Those who got the booklet, they may start solving. Those who don't have the booklet, they can see question on the screen as well. Okay, so start solving it. Once you are done solving it, let me know. We will discuss this. Okay, understand. I guess both of you are done solving this. Let's quickly discuss the answers. Okay, explain how the hardness of an X-ray beam is controlled by accelerating voltage in the X-ray tube. So, if you are increasing the voltage, you are increasing the kinetic energy of electron. If you are increasing the kinetic energy of electron, you are actually increasing the energy of emitted photon. And increasing the energy of photon means you are increasing the penetration power. Did you mention the same thing? Okay. The attenuation of a parallel beam of X-ray radiation is given by the expression where mu is a linear attenuation or absorption coefficient and X is the thickness of the material through which the beam passes. What is meant by attenuation? Attenuation means loss of power, loss of energy, or loss of intensity. Why the expression applies only to parallel beam? Because if we are using diverging beam, intensity will even decrease without passing through anything. So the formula we are using is valid on parallel beam only. The linear attenuation coefficient of for the X-ray bone and soft tissues are 2.9 per centimeter and 0.95 per centimeter respectively. Calculate for a parallel X-ray beam the ratio. Yes, Amna, what are you getting as the ratio if you have calculated this? Amna, can you hear me?
Yes, sir. Can you explain?
Okay, I will surely explain. See, the formula says I over I naught is e raised to minus mu into x. Now, if you want to apply this formula for a bone of thickness 2.5, you will write e raised to minus what is mu for bone. If you look at the value of mu for bone, what is it? 2.9. So it will become minus 2.9 into 2.5 because mu is 2.9 and thickness is 2.5 divided by. Now, if I apply this formula for soft tissue, it will be minus. Now, what is mu for tissue? 0.95. And what is the thickness? 6.0. I'm not getting it.
Like that? Yes, sir.
Okay. Now, if I want to calculate this, because your calculator can easily calculate e raised to power this. So if I calculate this value, what we will be getting? Yes, Anas, what are we getting as the answer?
Sir, 0.21.
0.21. And if Amna, you don't know how to do this, see, in your calculator, there is a button which says ln. If I press shift and ln, I will get e power. Now feed the value minus 2.9 into 2.5. You are getting 0.000710. And if you want to solve in one step, you can divide this value once again by shift ln and it will be minus 0.95 into 6. So we are getting 0.212. 0.21. Since we need answer in two significant figures because 2.5, 6.0 are two significant figures, so we will be getting 0.21 as the answer. So Anas is getting the same answer. And Amna, are you getting it? How we were supposed to solve it?
Yes, sir. Slowly getting it.
Okay. So now we will resume from in next class. In next class, we will be solving at least 2-3 more questions on X-rays. And hopefully we will be able to discuss at least either ultrasound or MRI. I will be teaching at least one of the techniques. So I will resume from here in next class now.